Questions 21 to 25 of the 2000 Grade 9 Pascal Math Contest. ABCD is a rectangle with AD equals to 10 and the shaded area is equal to 100. Then the shortest distance between the semicircles is. So here's ABCD and they're saying that AD is 10. And they're saying that this shaded area has an area of 100. So what I'm going to do is going to start labeling this diagram. The first thing I want to do is draw a radius. That will be the representation of the radius of the circle. And similarly on the other side, on the bottom, we have the same thing. And then I'm also going to extend it to the sides to show that that is also a radius. And just from the diagram, I hope you can clearly see that if this is the radius, then that is the radius, and that is the radius. And therefore 2r is equal to 10. So r is equal to 5. So this distance is 5, this is 5, 5, and 5, like that. And then on the side, DC, this big long thing right here, that is of course the length of the rectangle. So what they want us to find in this question is the distance or the shortest distance between the semicircles. So that would essentially be right there, that red line I just drew. And that red line we can call L minus 10, right? Because the whole thing is L, and then you got 5 here and you've got 5 there. So it'd be L minus 10. That's what they want us to figure out. So we obviously have to figure out the length. Now the area of this shaded region is equal to 100 according to the question. Now what is the shaded region? It's basically the rectangle. From it you're subtracting 2 semicircles. Correct? Like that. So the area of a rectangle, of course, is length times width. And then 2 semicircles. Each semicircle would have an area of pi r squared divided by 2, like that. So you have 100 is equal to length. The width we know is 10. And then these 2's cancel. We get pi. R is 5. So we have 5 squared like that. And therefore 100 is equal to 10L minus 25 pi. And we can isolate for L, 100 plus 25 pi is equal to 10L, and therefore L is equal to 100 plus 25 pi divided by 10. Okay? And finally, we need to figure out L minus 10 because that is what they're asking for, the shortest distance between those 2 semicircles. So L minus 10 would be 100 over 10. I'll just split up that fraction. 25 over pi over 10 minus 10. Well, 100 over 10 is 10. Minus 10 was 0. So you're just left with 25 pi over 10 or 2.5 pi. And therefore the answer here is A. A wooden rectangular prism has dimensions 4 by 5 by 6. This solid is painted green and then cut into 1 by 1 by 1 cubes. The ratio of the number of cubes with exactly 2 green faces to the number of cubes with 3 green faces is. Alright, so the first thing to do is to draw a diagram. So there you go, you've got a rectangular prism. And I've drawn it with the dimensions that they've given us, 4 by 5 by 6. And what they are going to do is they are going to paint this whole prism green all the way across like this. So I'll paint it. And once it is all painted green, they are then going to cut the cubes into 1 by 1 by 1. And when they do that, some of these cubes will have exactly 2 green faces, and some of them will have 3 green faces, and they want you to figure out that ratio. So how many have 2 green and how many have 3 green faces? All right, so what we can do is look at this diagram and try to figure this out. So I'm going to start first with the 3 green faces because there's one staring right at me, and that's this one right here, the corner. The corner, when you break apart this prism into individual 1 by 1 by 1 cubes, that will have 3 green faces. And similarly, all the corners will, because all the corners are essentially the same. So all these guys. So how many corners do we have? We got 4 up there, we have 4 down here, right? And therefore, the total number that will have 3 green faces is 8, because we have 8 corners. And I'll just write the word corners in there just so that you know. Now we get to 2 green faces. So look at this diagram carefully. How many will have 2 green? Well, I think the ones that have right up there, these ones will have 2, and you can clearly see that. And then similarly over here on the side, these ones have 2 green faces each, and this diagram will have a lot of symmetry. So if there's 3 here, there'll be 3 over there. If there's 2 here, there'll be 2 over here. So on the top, looks like we have 3, 3, 2, 2, 10 that have 2 green faces. And if there's 10 on the top, there'll be 10 on the bottom. It's because the bottom essentially is the exact same, right? All right, now what about in the middle of this diagram? Well, what these ones on the side will have 2 green faces. And there's 4 of those. Similarly, there's 4 of these on this side, 4 on that side, and 4 on the other side that you can't see. So 4, 4, 4, 4, 16. So the total with 2 green faces will be 10 plus 16 plus 10, like that. So this ratio is therefore 36 over 8. If you reduce this to lowest terms, 18 over 4 or 9 over 2. And therefore, the answer to number 22 is 8. The leftmost digit of an integer of length 2,000 digits is 3. In this integer, any 2 consecutive digits must be divisible by 17 or 23. The 2,000th digit may be either A or B. What is the value of A plus B? All right, so we've got this big, long digit. I mean, it is long, 2,000 digits. All right, all the way to the last digit. And they've told you that the very first or leftmost digit, very first, is a 3. And this is all, there's 2,000 of these digits. And the last is either an A or a B. So we have to figure out what is A, what is B, and then in the end we have to figure out A plus B. All right. And they've given us some rules that anytime you have 2 consecutive numbers, those numbers have to be divisible by 17 or 23. So what I'm going to do on the side here is write down all the multiples of 17 and 23 because that is going to help us. So we have 34, 51, 68, and 85. We don't need to go any further because we only have to be considered with 2 consecutive digits, so a two-digit number. So multiples of 30, what's the other one? 23. 23, 46, 69, and 92. All right, so let's go through this, and I hope you'll understand as I go through it how this number is being created. So 3 is what they've given us. Now the next number that I put in here, if I put in any number, this total number, whatever it is, must be divisible by one of these guys, or one of these guys. All right, well, our first digit is 3, so which one of these has a 3? The only one is here. That's it. So this has to be a 4, right? Because any two consecutive digits must be divisible by 17 or 23. If I put in a 34, it is indeed divisible by 34. So that works. I can't put in any other number there. Now let's go to the next one. I've got to put in a number here. And if I do, this number has to be divisible by one of these 9 numbers. Well, the first digit is a 4, so the only one that starts with a 4 is 46. So I've got to put a 6 here. Okay, so I hope you understand how this is going. All right, now I have to choose a digit here. And if I do, this 2-digit number will be, or must be, divisible by one of these guys down here. So 6, well, I got 2 choices, 68 or 69. All right, well, let's put 68 first and see what happens. Okay, and then later on I'll do the 69. All right, next one is that digit. So same story here. I've got to figure out which one of these I can choose. Well, the only one that begins with 8 is 85 right there. So that has to be a 5. All right, so I hope you understand how this is being created. Let's keep going. 50 something. Well, there's only one possibility, 51. That's the only way I can make a 2-digit number divisible by one of these, which is a multiple of 17 or 23. How about 1? All right, that's got to be a 7. Okay, now I've got a 7. What do I do now? I'm stuck. There's no number in here that starts with a 7. Yeah, so I am stuck. There's nowhere I can go. Stuck. That's it. That's the end of the road. And somehow, some way, this 8 got chopped. This was an 8 here. So I hope you followed that. Even though we got stuck, we did everything correct. So now what we have to do is we have to start this over. But this time, when we get to 6 right here, we've got to choose 69. All right? So let's do this again. Let's draw out our numbers here. And keep going. Like that. All right? All right, so we'll use black this time. First number they've given us is a 3. If it's 3, it has to be 34. No other choice. So that goes there. If it is a 4, it has to be a 6, right? Because 46 is the only one that we can choose. If it's a 6, all right, last time we chose an 8 and we got stuck. So we don't want to choose this guy here. We want to choose this number, 69. So I'll put the 9 there. Okay? And then now we have a 9. So from this, 92 is the only one that's possible. So I put a 2 there. And if I put a 2, what's the next number? The only possibility is 23. Like that. And if it's a 3, then it becomes 34. All right? If it's a 4, it becomes a 6. And if it's a 6, again, this is the bad guy. Don't go there. We don't want the 68. We want this number right here. So we got this. And I think this is repeating itself, because if we put a 9, it's got to be a 2. Yes, indeed it is. Right. So this is how it's going to go. It's going to be 3, 4, 6, 9, 2, and so on. So it just keeps going like that. So that means that every 5th digit will be a 2. So the 5th digit, the 10th, the 15th, the 20th, 25th, and so on, right? So every multiple of 5. The 2000th digit, well, 2000 is a multiple of 5, right? Because the 990th, 995th, and 2000th digit will all be 2s. So that means one of these is a 2. All right? Now, what happened? What about B? What's B? We got stuck up here, and this is the only other option. So what do? What's B? Have no clue, right? Well, here's what you have to understand. Yes, you got stuck when you reached the 7 right here, right? You can't move forward after that. So the only way to proceed is right here. These 3, 4, 6, 9, 2, and so on, right? And that is the only way you can proceed. So you keep doing that, and you get up to the very end. So you got 3, 4, 9, 2, 3, 4, 6, 9, 2, sorry. Like that. And this is your 195, your 1995th digit. And you've got the last 5 digits, right? Okay, let's figure out the last 5 digits. If there's a 2, it's got to be a 3, okay? If it's a 3, it's got to be a 4. If it's a 4, it's got to be a 6. If it's a 6, it can be this one or this one, correct? If I put in 9 for the 69, it'll just be 9. But if I put in the 68, it becomes an 8. And since we only have 1 digit left, we can squeeze in one more before we get stuck. All right? Now watch, if I use the 9, this one here, it will be 92. So the last one is 2. But this is what we already figured out. But how about if it's an 8? Then the last one would be a 5. So it is possible to have another digit as 5 because I have not got stuck yet. I will get stuck once I get to the 7. So this is a very good question, very intelligent question, one of my favorites actually. So finally, what is A plus B? Well, A plus B is 2 plus 5, which of course is equal to 7. So the answer to number 23 is B. There are 7 points on a piece of paper. Exactly 4 of these points are on a straight line. No other line contains more than 2 of these points. 3 of these 7 points are selected to form the vertices of a triangle. How many triangles are possible? So the first thing they have is a straight line like this. And they are telling you that exactly 4 of these points are on a straight line. So 1, 2, 3, and 4. All right. And there's 7 points on this piece of paper. And no other line contains more than 2. So we'll put 2 over here. And there's only one more, so we'll put the last one there. Does this diagram satisfy our criteria? Well, let's read it again. There are 7 points on a piece of paper. We have 7 points. 1, 2, 3, 4, 5, 6, 7. Exactly 4 of these points are on a straight line. Yes, indeed, right there. No other line contains more than 2 of these points. All right? So I'm assuming there's another line here like that. And no other line contains more than 2. That's also satisfied because this line only contains 2. And therefore, 3 of these 7 points are selected to form vertices of a triangle. All right, we can move with this. The first thing we need to do, of course, is label them. These points, B, C, D, E, F, and G, like that. Okay? And in order to create a triangle, you need to choose, of course, 3 points and then connect them. So we have the following scenarios. We can choose from here, and from here. All right? So the first scenario is from this point, you choose 0 points. From this area, you choose 2. And from this area, you choose 1 vertices. All right? And therefore, we will write down the triangles that we get. So if we choose 0 from here, we don't need to worry about this. Okay? We've ignored it at this point. But we're going to choose 2 from here. So for example, C and D. So our first triangle is C, D, G. Right? I hope you understand how I did that. And therefore, following this pattern, let's create all the triangles. 2 from here, 2 vertices from here, and just 1 from there. So C, D, G, C, E, G, C, F, G. And then D, E, G, D, F, G, and then finally E, F, G. All right? So I hope you understood how I did that. And this is a total of 6 triangles. And just make a little table there, like that. So we got 6 so far. Now, I'm going to create a triangle, but using all 3. So 1 from this column, 1 vertice from this column, and 1 vertice from that column. And this is going to give us about 8. A, C, G, A, D, G, A, E, G, and A, F, G. And then B, C, G, B, D, G, B, E, G, and finally B, F, G. And this gave us 8. Okay? So far, I hope you are following me. Next scenario is 1 vertice from here, 2 vertices from here, and 0 from there. Okay? So let's see what this gives us. All right, here we go. A, C, D, A, C, E, A, C, F, A, D, E, A, D, F, and A, E, F. Now let's work with B. B, C, D, B, C, E, B, C, F, B, D, E, B, D, F, and finally B, E, F. So this gives us 1, 2, 3, 4, 5, 6, and another 6. So this gives us 12. All right. Moving right along. Our next scenario is 2 from this vertice, none from there, and 1 chosen from here. So that would give us the following triangle, A, B, G. That's the only one possible. So that's 1. And I believe we are at the very end of our question. And that would mean the final scenario, which is 2 chosen from this area, 1 vertice from here, and 0 from there. And that would give you the following triangles: A, B, C, A, B, D, A, B, E, and A, B, F. So that's 4. So the total, 6 plus 8 plus 12 plus 1 plus 4, that is 31. 31 total. So I hope you understood how I did it. It's a very nice systematic way of doing this. So 31 is for number 24, D. In triangle ABC, it is an isosceles triangle with AB equal to AC equal to 10. All right? And BC is 12. The points S and R are on BC such that BS to SR to RC is 1, 2, 1. Okay? The midpoints of AB and AC are P and Q respectively. Perpendiculars are drawn from P and R to SQ, meeting at M and N respectively, the length of MN. All right. All right, so let's draw this out a little bit bigger. So first, let's start labeling this. Well, AC is 10, and AB is also 10, and BC is 12. And then these sides here, they've given us the ratio. It's 1 to 2 to 1. So if this is x, and this is 2x, correct? And then the total is 12, so that means 4x is equal to 12, and therefore x is equal to 3. So this is 3, and this is 6. Okay? The midpoints of AB and AC are P and Q. So P and Q are midpoints, so therefore from here to here is 5, and from here to here is 5, and similarly from here to here is 5, and from there to there is 5. And I think in terms of labeling, that's all we have so far. And I now need to start drawing in some relationships. So I'm just going to draw this perpendicular here from P to S, like that. And then I'll draw one right across from P to Q. And I think that should be it. I think that's all we need to solve this question. All right? So far, I hope you're following me. You can do this, even though it's number 25. Just follow me. I promise you, you will understand it. So far, no problems, right? Okay. So here we go. The next step is I want you to look at triangle PSQ. This one right here. PSQ. This triangle. That triangle is a right triangle, correct? So I drew it over there just so I wouldn't make this diagram messy. So this is P, this is S, and this is Q. And here's a right triangle. Now SQ, we can create a Pythagorean relationship, correct? Now how do we do that? Well, I hope you figured out the length of PS. Well, what is it? Well, from here to here is 3, and from here to here is 5. And then therefore, this is a 3, 4, 5 triangle, right? And you can prove that with Pythagoras, pretty simple, but 3, 4, 5 triangles are a very common Pythagorean relationship. So that means PS is 4. PQ is also known. PQ from here to here is also known because it's the same as SR. I think if I drew another perpendicular from Q down to R, it would probably be a little bit more believable that PQ is the same as SR. That PQ is the same as SR. All right? So if SR is 6, PQ is 6. So now using Pythagoras, we can solve for SQ squared, or SQ rather. That's 4 squared plus 6 squared, which looks like 16 plus 36. So therefore, SQ is equal to the root of 52. Okay? So that takes care of that. Let's move this up a bit, because we're going to need a little bit more space here. All right. So now, where do we go from here? Now I want you to concentrate on the following triangles. The first one is this one right here. I'll draw it in red. SMP, that one right there. This one, SMP, all right? In that triangle, we have SM squared plus PM squared is equal to 4 squared, correct? I want you to be convinced of that. So that means PM squared is equal to 16 minus SM squared. Okay? Strictly from Pythagoras, no tricks. Then I want you to look at the following triangle, PMQ. PMQ, this one right here. In that triangle, we have PM squared plus MQ squared is equal to PQ squared. And PM squared, therefore, plus MQ squared, PQ we know is 6, so it becomes 36. And therefore solving for PM squared is 36 minus MQ squared, like that. All right? So now we have PM is equal to 16 minus SM squared, and we have PM squared is equal to 36 minus MQ squared. And therefore we can set them equal to each other. So that means 16 minus SM squared is equal to 36 minus MQ squared. Like that. Now, before I continue with this equation, we have to get this in terms of one variable. But look at the relationship between SM and MQ. Here's SM. Here's MQ. What is the relationship? Well, SM plus MQ is equal to SQ. Correct? And SQ, we figured out up there was root 52. So that means we can say that MQ is equal to root 52 minus SM. And we can use that to substitute into here. So let's do that. We've got 16 minus SM squared equals 36 minus root 52 minus SM. Like that. All squared. All right? And then instead of having to write out SM every time, I'm just going to let it equal whatever variable you want, y. It just makes it simpler. So now I've got 16 minus y squared is equal to 36 minus root 52 minus y, all squared. All right? So we have to now solve for this. 16 minus y squared is equal to 36 minus 52 minus 2 root 52 plus y squared. 16 minus y squared is equal to 36 minus 52 plus 2 root 52 minus y squared. The y squareds disappear because they're the same on both sides. This should be a y, sorry. Right there. Don't make that mistake. All right, so what do we got? 36 minus 52 and plus 2 root 52y. Okay, so we're getting pretty close to solving this. Put everything on one side. 16 minus 36 plus 52. And this looks like minus 20 plus 52, which is going to be plus 32, 2 root 52y, and therefore y is equal to 16 over root 52, like that. There you go. Now, what were they asking for in this question? They're asking for the length of MN. All right? Shouldn't be too bad to figure out MN. MN is what? MN is from here to here. This guy right there. So MN is essentially SQ minus 2SM. Why? Because SM is the same as NQ. because of the symmetry of that diagram. Okay? So let's figure out Mn. So therefore, finally, Mn is equal to SQ minus 2SM. SQ we figured out way at the very beginning is root 52. And 2 minus SM, well, SM was y, and y is equal to 16 over root 52, like that. All right? So we just have to figure this out right here. So let's see, top and bottom, root 52, trying to get a common denominator here. Minus 32 over root 52. So this looks like 52 minus 32 over root 52. And this is 20 over root 52. And I think the root 52 we can simplify a little bit more because it's 4 times 13, correct? Like that. So then therefore this becomes 20 over 2 root 13. And finally that's 10 over root 13. 10 over root 13. And therefore the answer is 25 is B.